Hi everyone, and welcome back to our next video. In the last video we looked at how we can take a block program and convert it to text, specifically C++. In this video we're going to take another look at how we can do that and some of the reasons why we want to do that. Text allows us to do things that block programming can't. We can be more creative, it's less restrictive, so that's why we want to slowly switch to working with text programming. So let's take a look first at a block program that we are going to create, and then we're going to convert that to text and play with that. So first thing, we're going to create a variable and let's call it time. You'll see how we're going to use this later. And first thing we're going to do is we're going to set that time variable equal to 0. And then here's what we're going to do. We are going to set our LED on, which is pin 13. So let's turn it high. And we want to hold it for a certain amount of time. And then what we're going to do is we are going to set that pin 13 low. We're going to turn off the LED, and then we're going to hold that for a certain amount of time. So there, our program looks pretty simple. That's all it does. But we're going to change something here. What I'm going to do is I want this flash rate of the LED to be controlled by this potentiometer. The potentiometer is connected to port A0. That's an analog port. Remember, it can receive voltage here from 0 to 5 volts, and it converts it to numbers from 0 to 1023. That's a 10-bit number. So we can use that 10-bit number to help control the flash rate of our LED. So how can we do that? We're going to go to input, and we're going to go to read analog pin A0, and that's how long the wait time is going to be. So if I put this right here, and if I do it again down below, there, now what it's going to do is it's going to read the value from the analog pin A0, and that's going to be the wait time. So that's going to control the flash rate. Now if I try to go and run this program, let's just see what happens. So it's turning on as we expect, but it's not flashing, and there's a reason why. The input value to A0 is a voltage, but it converts it to a number from 0 to 1023. If it's, let's say, 1000, then it's actually waiting for 1000 seconds. Well, we don't want to do that. We want it to be faster than that, and you can see that it's off now, and we want to control that better. So what we're going to do is we're going to take this program and we're going to convert it to text, and then we can play with the text, we can edit it quickly and get it to do what we want. So I'm going to go to stop simulation. I'm going to go to this here, click on blocks, and I'm going to convert this all to text. Remember, we get a warning when we do that. Once we convert from block to text, you can't go back to blocks, so it's just warning us that that's the case. So we're going to go continue, and there we get this here. So here's our code here. We have that variable called time. It's equal to 0, and this is how it sets a variable in C++. We have the type of variable. It's an integer represented by int. Integers are numbers 0, 1, 2, 3, and so on, -1, -2, -3, and so on. No decimals, no fractions, and it sets that variable equal to 0, followed by a semicolon. Then we have the void setup, and remember from the last video, this is where pins get set up. In this case here, we use the pin mode command to tell pin 13 that that's going to be an output pin. We're telling pin A0 that's going to be an input to our program. So that's what void setup does. It only runs once at the beginning, and then this function here runs. This loop runs over and over and over. And what it does is it set that time variable equal to 0, and then it did a digital write. It sets pin 13 to high, and it delays it for 1,000 times what we call analog read. Analog read is the command to read the information from port A0. That's what it looks like in C++. Now, if it's equal to 1,000, that's 1,000 milliseconds times another 1,000. That's going to be really long. So what we're going to do is we're going to take this part out here. We're going to take out this 1,000 times. So here's an example where we can go in and edit, and we can quickly change things to get it to do what we want instead of worrying about the block program. So it's actually going to wait for the length of the analog time like so. Then if we try this now, let's see what happens. So we're going to go start simulation. And there, now it's flashing fast. And we can change this here. It's a little bit slower. We can change this here again and make it a little bit slower again. So there, we've quickly gone in, we've edited the text, and we've got it to work more than what we had before. It was flashing too slow before, so we can do that. Now, we haven't talked about this variable time yet. Let's see how we can use that in this program if we wanted to. I'm going to go in and I'm going to stop the simulation in order to edit the code. And what I'm going to do is I'm going to say set time equal to analog read. So I'm going to use one of the commands here. I'm going to read A0 like so. So what this line does is it takes the value from the analog input A0 and it puts whatever number that is into the time variable. And then what I can do is I could go here and say I want you to delay for that length of time. So I'll put in time here, and let's do the same here. So the program's going to do exactly what it did before, but maybe it's more intuitive now. You can see it's going to delay a certain amount of time, and that time is based on what it's reading from that analog port A0. So let's go and start the simulation. And sure enough, it's flashing as expected. If we rotate this back, it should go faster, and it does. If we go back and move it back more, it's even faster. So there, we've gone in and edited the program in C++ in text, and we've made some changes really quickly. And like we said, you're going to find the text more versatile. It's less restrictive. We can be more creative to do different things. So that's it for this video. I suggest you open up Tinkercad and try it, and try to get the same thing to work. That's it for this video. We'll see you next time.